students. Today we're continuing with your linear equation in two variables. This is your part 5. Since we have done the methods that we can use to solve a pair of linear equations, now we're finding out real life applications, actual applications, word problems. We're going to apply our skills, our knowledge on how to solve a pair of linear equation using substitution, elimination. We are not going to use the graphical method. And the better, if you want, you can use the cross product method also, but I don't prefer it. So substitution method and the elimination method, like I have told you in the previous classes, the previous video, I want you to sync it. I want the knowledge to be sinking unless and until and unless you understand the substitution and elimination method better. Not watch this video, you watch the elimination and substitution method repeatedly. So before we go into the word problems here, we need to understand a few things as an introduction. So first one is two-digit number and their interchanging. Second one, speed, time, and distance. And third one is boats or steamers. And profit and loss, profit percent, loss percent. This one you have already learned. This one you have already learned in physics class 9. Number 4, you have already learned in class 9, 8, profit and loss chapter. There was one, right? In class 8, mathematics. And then the fifth one is regarding age. What I'm giving here is just an introduction. When there is a certain type of wording in a word problem, if you know this introduction properly, then you will be able to understand what this mean exactly. That's why I need to give you this concepts as introduction first. First of all, two-digit number and their interchanging. Okay, look closely. You are going to face this once more in quadratic equation word problems also. So this number 1, it has applications in 2 chapters, or linear equation in 2 variables and quadratic equations also. So two-digit number and their interchanging. Look, let's say I have a two-digit number. Let's say 12. If I add 9, then what do we get? 21. Look, it used to be 12. What digits are we having? We have 1 and 2. 1 is in the tens place and 2 is in the units place. Now, after we add the value of, we add 9, the 1, 2, the 12 has changed into 21. The digit still remains the same, right? We use 1 and 2, but 2, instead of being in the units place, it has turned into the tens place. And 1, instead of being in the units place, instead of being in the tens place, it has turned into units place. I can give similar examples like this. 35, if I add 8 here, if I add 18 here, what happens? It becomes 53. I want you to focus on these two numbers, 35 and 53. They consist of the same digits, right? They consist of 3 and 5. What is the difference? The 3 was in the units place here, but the 3 was, 3 was in the tens place here, and 3 is in the unit place in 53. So algebraically, how are we going to represent this? That's what I wanted to talk about. Let's say you have 35. 35 can be broken down like this, right? 30 plus 5, 3 into 10 plus 5 into 1. Look, 3 is in the tens place, that's why it is multiplying with 10. 5 is in the units place, that's why it is multiplying with 1. One more example, 67. Look, 6 is in the unit tens place, so we can write 6 into 10 plus 7 is in the units place, just write 7 into 1. So from these two examples, what we can understand is, if you have two digits which consist a two-digit number, then let's say the tens place is x, the units place is y. How are you going to make the two-digit number? That's the question. Here, it's easily known. If the 3 is in the tens place and 5 is in the units place, you can just put 3 and 5 like this. But in terms of multiplication, addition, how are you going to make it? That's how. Let's say I don't put 3 and 5 or 6 or 7. Let's say I put x and y. So in that case, how are we going to make the two-digit number? The two-digit number is going to look like this. X, let it be in the tens place. If I want this in the tens place, if I want this y in the units place, the number will look like this. X into 10 plus y into 1. Okay, if I don't have x, y, if I replace the x, y with a and b. A is in the tens place. Tens place is and B is in the units place digit. So what's the number now? The number, okay, you have seen the example here. The tens place will be multiplied with 10. This A, multiply it with 10. A will be multiplied with 10. B is in units place, so we will multiply it with 1. So we have got 10A plus B. That's how you make a two-digit number if the tens place and the units place digits are given. What if you are asked to interchange it? 67, if you interchange the digit, we are going to get 76, right? But you are given A and B. The number is like this, 10A plus A, 10A plus B. If I want the digits to be interchanged, look, if 67 is interchanged into 76, the digits in units place become tens place. The digit in units, the digit in tens place become units place. Digit in units place become tens place. So if I want to reverse the digits, then in this one you have to reverse it. B will be in the tens place, A will be in the units place. So what is the reverse number now? The reverse number will look like this. The reverse number will be, now the B was in units place, so it was multiplied by 1. Now B will be in the tens place, B will be multiplied with 10 now, and A will be multiplied with 1. What are we getting there? 10B plus A. If we have A in tens place and B in units place, what is the number? 10A plus B. You know how we obtain this, right? If I reverse the digits or if I interchange the digits, then the number that we are able to obtain is, instead of 10A, we will have 10B, plus instead of B, we will have A. That's it. If I use X and Y here, same thing, 10X plus Y, here also 10Y plus X. Okay. So that's how this is going to look like if we are given a two-digit number. If we are given a problem related to two-digit number, you are going to write the two-digit number like this. If you interchange the digit, you are going to write the number as this. Okay, first one is over. You will understand this more when we do actual real life, actual real questions. Okay, next come to the number 2. Yeah, speed, time, and distance. Speed, time, and distance. I just want to remind you all what is the relationship between speed, time, and distance. Let's say we take a car. So there is 240 kilometers between A and B. If you cover this 240 kilometer in 2 hours, what is the speed? The speed will be distance divided by time. You can do cross multiplication. Distance is equal to speed into time. You can find the time also. If I want time, then speed will come here in the left hand side as denominator. So if I want time, we are going to have distance divided by speed. So once you know these three formulas, speed is equal to distance by time. So how to calculate distance? You just cross multiply speed and time. And if I wanted time, then it is distance by speed. You have already known this. I believe you have done 1 or 2 questions in class 9 also. So very simple one, speed, time, distance. I just need you to understand what is the formula for speed, what is the formula for distance, and how do we find out time if distance and speed are given. So coming to this problem here, if we travel 240 kilometer distance in 2 hours, what is the speed then? We put the distance as 240 divided by 2, time is 2 hours, cancel it, 120 kilometer per hour, very fast. Okay, so I believe this is a simple one. Next one. So next one, boats, steamer, upstream, downstream, still. Okay, let me show you situation here. This is the river. Okay, I'm just sloping it. I'm just showing it as a little bit of a slope. This is the river. Here we are. Here is a boat. Here we have a boat here. Which one will be easier, going downwards or going upwards? If a river is flowing in this direction, then going against that direction is called as upstream. If you are going along the direction of the river, along the direction of flow of water in the river, then it is called as downstream. Which one will be more difficult? It will be more difficult to go upstream, because if you are going in this direction, then the water is against the boat, right? So by the laws of physics, two quantities which are opposite in direction, they will subtract each other out. So, and then one more thing still, I have a speed going this direction, I have a speed going this direction. I mean the speed of the boat, okay? Speed of the boat going upstream, speed of the boat going downstream. There are two different values. Which will be more? Upstream will be less, downstream will be more. But what is the actual speed of the boat? the actual speed of the boat, it cannot be determined in the river, because if you go downstream, then the water is helping the boat. If you go upstream, the water is against the boat. So if I want the actual speed of the boat, then you have to put the boat in what? You have to put the boat in a water like a lake where the water is very still. The water is at rest. So the speed of the water, the speed of the boat when we measure in a place like a lake where the water is not flowing, that's the actual speed of the boat. So actual speed of the boat, we call this as speed in still water. Still water means the water is at rest, the water is not moving, okay? Then the water is flowing in the river. The water must have a speed flowing downwards, right? So it must have a speed. So we will say the speed of the water in the river or stream. Okay, we have two moving things here. One is the boat itself. The other is what? The water in the river or stream. So if the speed of the boat is x, let's say I take the speed of the boat in still water as x, I take the speed of the water as y. Then let's look again at the speed of the boat when it goes downstream or upstream. If it goes downstream, then the water in the river will be helping the boat. Okay, the boat is going this direction, the water is also going this direction. So by the laws of physics, if two quantities are in the same direction, then you have to add them. So if I want to find out speed of the boat downstream, downstream means the water is helping the boat, right? So we will add these two quantities. We will add the speed of the boat and speed of the water. We will add x and y. So we are going to get x plus y. If I go against the water in the river in this direction, the boat is going in this direction, water is going in this direction. The two are opposite. So by the laws of physics, you have to subtract them. So speed of the boat, let me write with blue. Speed of the boat, in case the boat is rowing upstream, then we have to subtract the two speeds. We will subtract x and y. Why? Because one of them is going in this direction, the other is going in this direction. The two directions are opposite. Okay, so this much for boats, steamer. We will surely face one or two problems in your exercise 4.3. Okay, then the remaining profit and loss, profit percent, loss percent. Let me just recap. Let me just remind you about the knowledge that you have learned in class 8. Profit and loss, profit percent, loss percent. Let's say I am a merchant. Okay, I am a shopkeeper. Let's take just one item. Let's take just one item, this box A. I bought it from a local dealer at rupees 10. Then I sell it at rupees 15. The price that I bought, that is called what? That is called cost price. The amount, the money that I get by selling the object, that's what we call it as selling price, right? So the difference is my profit or loss. How much is the difference here? 10 and 15, 15 minus 10, we will have 5 rupees as the difference, right? The difference is what now? It's profit or loss. Profit when, loss when? Profit when if the selling price is greater than the cost price, right? Loss when it's the other way around. If the cost price is greater than the selling price. Now coming to percentage, profit percent. Profit percent is calculated like this: profit divided by CP multiplied by 100. And if I want to calculate the loss percent also, we will use the same formula, except the profit will be replaced by loss. So we will have loss divided by CP into 100. Okay, now what if we wanted what if we are given profit percent and loss percent, and we want the profit, we want the loss? What then? In that case, we will find out profit like this. Profit is equal to profit percent into CP. You just have to let down the profit percent as profit by 100, right? So if I want to find out the profit, then it's profit percent into CP. If I want to find out the loss, then it will be loss percent into CP. You should know that in calculating profit percent, loss percent, or profit and loss, only cost price is involved. Selling price is not involved, okay? Selling price and the relationship between profit price and cost price, you have already known it earlier. So I don't think I need to repeat it. So just reminding what is profit percent, loss percent, and how to find out profit and loss if the profit percent and loss percent are given. Okay, that's it for profit percent, profit loss. Okay, come to age. Okay, we are going to face one or two problems that is related to age. For age, you will face questions like 5 years earlier. Okay, 5 years hence. So if you come across words like this, 5 years ago or 5 years earlier. Let's say I take two persons. Let's say I take a mother and son. Okay, mother and son. Let's say the mother's age is X, the son's age is Y. Now you have to question, when did we measure the age of mother and son? Is it right now, or is it afterwards, or is it before? So in the numerical, in the word problems that you are going to face, you are going to take the age of a person as the present x, the present age. So let's say I want to find out the age of a mother before, after, doesn't matter. You have to take the value of x and y as the present age. Okay, this is the present age, current age. So the age, present age of mother is x, present age of son is y. What is the age of the mother 5 years ago or 5 years earlier? Same thing, they represent the same concept. Okay. So age of the mother 5 years ago will be, the age of the mother now is how much? It's x. 5 years ago will be, from x we have to subtract 5. Okay. One more word that you are going to encounter, it's, let's say I say 5 years hence. 5 years hence means after. Okay. After means from the present age, you go 5 more years. 5 years age hence will be, from the mother's age, you have to increase 5 more years. And one more thing that you should always be cautious about, the students make these mistakes repeatedly. If mother's age is increased, the son's age should also increase. Okay, it is not like your mother grows older, but you remain the same. You remain as the youth. It doesn't happen like that, right? So if the mother ages, then the son ages. So if you add 5 on the age of the mother, you have to add 5 on the age of the son. If it's given father and son, also same thing. So if this is mentioned 5 years ago or 5 years earlier, then on the two quantities, on the two persons that you are taking the age of, you have to subtract 5 on each of them, x minus 5, then y minus 5. This is the age of son 5 years ago. This is the age of mother 5 years ago. If it says hence, then same thing, 5 more years, 5 more years, like this. Okay, that's it. That will be the foundation for you to understand the word problems in exercise 4.3. I would like to start the exercise 4.3 right now by picking up a question number 3. Look, what is the question saying? And then you should know that this is a linear equation in two variables. We want to take two variables. Okay, you take a, b, x, y, whatever your choice is. But I'm going to take x and y. Here, you have to find two unknowns. Two unknowns, and based on that two unknown, you have to find the solution, what the question wants. That's it. The sum of the digits of a two-digit number is 9. We have a two-digit number. If I add the two digits, then we get how much? We get 9. That's what the question saying, right, in the first line. Then next, if 9 is added to the number, the digits are reversed. If I add 9 to the number here, this is the units place digit. I'm just showing you symbol. Okay, this is the units place digit. This is the tens place digit. This is the units place digit. If I add 9 here, then what will happen? Then this will be reversed. The units place will become the tens place. The tens place become the units place. And what else is given in the first line? If I add these two, then we will get 9 also. The question wants to find the number. So the question is about a number which consists of two digits. I just show you in the beginning concept about reversing of digits, how a two-digit number is formed given the two digits in units place and tens place, right? So here for this question number 3, what is the unknown? The unknown is tens place and units place. Once we know these two numbers, then it will be easy to find out the number, right? Tens place will be multiplied by 10, units place will be multiplied by 1. That's how we found out the number. Tens place we will take it as x, units place we will take it as y. Whatever your choice is, okay, you can use y here and x here. But the important point is we have found out what is the unknown. What are the unknown? Unknown are tens place and units place. So let's start the solution. Let x is equal to digit in tens place. What about y? Y is the digit in which place? units place. Then you form the number. The number is what now? On the x, you have to multiply with 10. On the y, we have to multiply with 1. So we get 10x plus y. Okay, let me make this as equation number 1. The number is equation 1. Okay. What are the conditions given? There must be two conditions. Okay, look very closely. There are two conditions. First line is the first condition. Sum of the digits is how much? 9. Sum of the digits, what are the digits? X and y. If I add them, if I add x and y, how much is it? It's 9. That's the first condition that the question is giving us. X plus y is equal to 9. So you say here by equation. Okay, so equation number 2. Then the second line, it will give you the second condition also. If 9 is added to the number, what is the number? The number is right here, 10x plus y. If 9 is added to the number, if 9 is added, look, it will look like this. If 9 is added, so 9 is added to what? To the number. The number is this one right here, right? 10x plus y. If 9 is added to the number, what happened? The digits are reversed. What will happen to the digits? It was 10x plus y. X was in tens place, y was in units place. If the digits reverse, what will happen? This will be 10y plus x. That's it. That's the question. That's what the question is saying. Okay. So next condition is if I add 9 to the number is, then the digits will be reversed. Reverse the digit, 10x plus y will be changed to 10y plus x. Now let's make it into a proper equation, an equation that looks like this. Okay, ax plus by equal to c. X and y on the left hand side, constant term on the right hand side. So 9 plus 10x plus y is equal to, let's bring everything from the left hand side on the right hand side on the left hand side, equal to 0. I want a constant on the right hand side. 10x minus x, how much is it? It's 9x. I have y missing here. Y minus 10y, how much is it? They will subtract. So y minus 10y, we were going to get minus 9y, right? The minus is bigger, is equal to, I want the constant term. This one is the lone constant term, so take it to the right hand side. The plus sign will be changed into minus. Yeah, look, there are 3 of them. I can divide all the 3 terms with 9, right? If I divide all the 3 terms with 9, then 9 and 9 here will cancel. 9 and 9 here will cancel. 9 and 9 here will cancel. So what are we getting? X minus y minus 1. So if I divide both sides by 9, we are getting x minus y is equal to minus 1. This is equation number 3. Okay, now let's solve this. Let's solve these two equations right here. We want the value of x and y, right? If we get the value of x and y, then question wants to find the number. Where is the number? The number is here. We will put the value of x and y and we will get the number. Simple and easy. How to solve these two equations? As I mentioned, use elimination method or substitution method. So let's just put the equations right here like this. X minus y, x plus y is equal to 9. X minus y is equal to minus 1. Okay. So how to solve these two? You can use elimination. Just look, the coefficients are same. The coefficients are same, so you can add or subtract. If you add them, then y and y will cancel out. If you subtract, x and x will cancel out. Better if we add them, okay? So you just say here adding. Where do we get these two equations from? Equation 2 and equation 3. Adding 2 and 3, what do we get? Add them, x plus y and x minus y. X plus y and x minus y, if I add them, x and x, we are going to get twice x. Plus y and minus y will cancel out because they are same value but opposite sign, right? 9 and minus 1. 9 plus minus 1. How much is it? 9 minus 1, which is equal to 8. So x and x, we get 2x. 9 and minus 1, we get 8 minus y and y that cancel out. What is left? Implies that twice x is equal to 8. Find out x, 8 by 2, which is 4. Okay, let's substitute in this equation. What is this equation? It is equation 2. Putting x in equation 2, you can say substituting also, okay? So instead of x, we are going to put 4. What's the answer now? 4 plus y is equal to 9. This x is being replaced with what? With 4. Implies that how much is y? 9 minus 4, which is 5. Okay, we have got the values of x and y. What did x and y represent? You have to look at the beginning when you say let. Okay, now let's see another question here. This is based on the A's that I have just introduced. Okay, So look, question number 5. Look, the question says 4 years ago, a father was 9 times as old as his son. Next line, 8 years hence, the father will be 3 times the son's age. Find their present ages. Okay, look, what we are dealing with, what persons that we are dealing with here. We are dealing with a father and we are dealing with a son. One more hint, one more knowledge that I want you all to keep in mind is if something says x is 9 times y. If we have this situation, how to convert it into equation? It will look like this. X is will be equal to 9 times will be multiply and then you just put y. It will look like this. Okay. So here, look, we will come back to this later on. Look at the question. 4 years ago, father was 9 times as old as his son. This was a story about 4 years ago, right? This was a condition of the age between the father and the son 4 years ago. 8 years says 8 years hence. After 8 years, father will be 3 times the son's age. This is also for not the present, it is after 8 years. Question once, find their present ages. So the unknowns. First of all, you need to know the step. What is the unknown? What are the unknowns? Okay, there will be two of them. What else? Then what is given? What is given? What is the given condition according to the question? And then the last one, you have to solve using elimination or substitution method. Once we are able to determine the equation, that's very simple, right? So first step, you have to determine the unknown. The question wants us to find the present ages of what? Father and the son. So let's take the age of the father. We need the age of the father. We need the age of the son. Father's age, let's take it as x. Son's age, let's take it as y. So mention here solution, let x is equal to is when. I just have mentioned in the beginning of this lecture that you have to take the age as the present is, right? So mention here x is equal to present age of father and y is present age of the son. Okay, now we have determined the unknowns. Now let's look for the given condition. What are the given condition? This is the given condition. This is the given condition. Okay, 4 years ago, what will be the age of the father 4 years ago? It's x now. For the son also, it's y. 4 years ago, it will be x minus 4. Same thing here, y minus 4. What is the relationship between the age of the father and age of the son 4 years ago? What was it? The age of the father was 9 times as old as his son. Age of father is 9 times age of son. We're talking about 4 years ago. Okay, age of father, in any way you don't use x because this condition applies only when the age of the father and age of the son is 4 years ago. So age of the father we will take x minus 4. Age of the son we will take y minus 4. So age of the father we will write it as x minus 4. Age will be turned into equal to, right? Equal to 9 times 9 multiplied with what is the age of the son? Age of the son is y minus 4. So that's your required equation right here. X minus 4 is equal to 9 into y minus 4. Okay, that's the first condition. And from the first condition, we are able to obtain the first equation also, right? Okay, so let's get the first equation. Wait a minute, please. So let's keep this first equation. There's something wrong. So let's just write here, age of the father is 9 times age of the son. Let's open the bracket. X minus 4 is equal to 9y minus 36. As I mentioned before, we want the variables on the left hand side, constant term, all of them on the right hand side. So we will have x minus 9y is equal to, this minus 4 will turn into plus 4 on the right hand side, right? Minus 36 plus 4, which will be minus 32. Okay, now we have got one equation. The one equation is x minus 9y is equal to minus 32. Make it as equation 1. Okay, next condition. Look for the next condition very carefully. 8 years hence. 8 years hence means the age of the father will be x plus 8 now. Same thing for the son also. What are the given condition? Age of the father will be 3 times the son's age. This will be 3 times this, right? So for the next equation, the given condition is age of father is 3 times age of son. Write it down in equation. Look, age of father, we are going to use what now? Don't use x, don't use x minus 4. This is a condition for 8 years afterwards. So AZ of the father will be X plus 8. Is will be equal to 3 times will be 3 into S of the son will be Y plus 8. This is another equation. So just write here by equation, say here also. Okay, because that's the second condition. Okay, let's continue on the right hand side. We just open the brackets for this equation right here. We do a little bit of transposition, bring X and Y to the left hand side and the constant terms on the right hand side. Okay, so what are we going to have? Okay, now X plus 8 is equal to, open the bracket, 3Y plus 24. I want 3Y on the left hand side and I want 8 on the right hand side. So we get 16 here, X minus 3Y. This is equation number 2. So you can use substitution and elimination method that I've just taught in the previous video. You can find out X from here and then you can substitute here. But most of the time I will be preferring the elimination method. Okay. Here, look, the coefficient of X is 1, coefficient of X is 1 here. So just subtract equation 1 and 2. So I'm just writing equation 1 minus equation 2. Write the equation 1 first. X minus 9Y is equal to minus 32. X minus 3Y is equal to 16. Since they are subtracting, I'm putting a minus sign in the front. So this plus sign will turn into minus. This 16 will turn into minus. The minus sign will be turned into plus. Plus sign will be turned into minus. Okay, these two got cancelled. What about this? Minus 9Y and plus 3Y. You don't take the original sign. Okay, you take the change sign. There is minus 9Y. Here is plus 3Y. So minus 9Y plus 3Y. How much do we get? We get minus 6Y. So let's just put minus 6Y right here. What about the remaining? Minus 32 minus 16. Okay, you don't get plus here anymore. You get to take the minus, the new sign minus. Minus 32 minus 16. Minus 32 minus 16. Since the signs are the same, we will add 32 and 16, which will be 48. Okay, so put 48 there. 48. Okay, now we wanted Y, right? So find out Y. Very simple. You just cancel the minus and minus sign. X and X are cancelled. So Y will be how much? 48 divided by 6, which will be 8. What about X? You put the value of Y anywhere. You put the value of Y in equation 1 or 2, your choice. I'm putting it right here. Okay. So putting the value of X of Y in 2. Okay, let's continue on the left hand side. Yeah, there's no more space. Okay, I'm keeping this. Okay, I'm keeping this. So if I put the value of Y in equation number 2, what do we get? X minus 3 into 8 is equal to 16. X minus 24 is equal to 16. So we get X as 16 plus 24, which is 40. Okay, now look closely. What we wanted was, we wanted the presentness of father, presentness of the son. The value of X and Y, we wanted them. Y we got 8, X we got 40. Question 1 is to find the presentnesses, right? Here are the presentnesses. So you say here, therefore, presentness of father, it's the bigger number. Presentness of son, what is it? It's the smaller one, which is 8. Okay, here are your solutions, 40 and 8. Okay. So with this, we're going to take up some more difficult problems, slightly difficult ones, slightly longer ones. In the previous board exams, most of the questions from your exercise 4.3, it will be either a 4 mark or sometimes very rarely there is a 5 mark question involved, but 5 marks doesn't come very often. You can expect a 4 mark question from this exercise 4.3 or from the solved example. For more examples, you can look up the previous year question papers also. You can look up which questions can be solved using the linear equations in 2 variables. We will take up more questions from exercise 4.3 in the next videos. With this, let's finish today's video. I will see you all on the next class. Goodbye.